Hello, sir. My name is Ray. Now I will begin my examination. The first step I need to take is to download the image data from this website. From this website to the local machine. After the download is complete, we can view the images locally. All the images are right here. And because I need to use this function named flow from directory function to read and automatically process the images, and this function has requirement for the structure of the image files. Therefore, I need to restructure all the image first. So I use this method to restructure the file restructure. So I use the list method to restructure the file structure of the images and also split the dataset at the same time. The file structure of the images after restructuring looks like this. Here we have 70% of the training site, 15% of the validation site, and the test site. And there are different classes, and the name is the class name, and the number is the class number, the number of class. So next, I used this method to perform the data augmentation on the training site. Only, including normalization, rotation, wide shift, height shift, zoom, and flip. However, the validation site and the test site only normalization. Validation site and test site only normalization. And I also set the image size is 128 by 128, and the bench size is 32. And then I also defined a callback to save the best model. So the best model and set the early stopping after five epochs, and record the log. And next, I built a CNN model and trained it. However, I found that training with local images take too much time. You can see that it will take too much time, and was not conductive to have a parameter optimization. So I chose to use the data that was exactly the same as the local images, but with a much faster training speed. It's right here. I directly imported the plant leaves datasets from the TensorFlow datasets library. And the name is plant leaves, and I split the datasets in the same method, like the 70% for training, 15% for testing, and 50% for validation. And I set the same image size, bench size, and normalization here. Bench size is is still 128, and the bench size is still 32, and it's still normalization for all of the data. And then I also set the same callback to control to monitor the validation accuracy, and save the best model like here, the best model and the channel log. And then a baseline CNN structure is created. It contains of 2 convolutional layers, each with 32 and 64 filters, and a dropout rate of 0.2. A fully connected layer with 128 filters, and hyperparameter optimization will be conducted based on this structure, and optimized hyperparameters include the number of layers, the number of filters, and the dropout value, they will be changed, and the learning rate, because this time the learning rate is default. The learning rate is set to the default value, and when I optimize the hyperparameter, the learning rate will be changed. It's right here, where it will zoom and or it will become smaller. And after training is completed, the best model under the different hyperparameters will be saved here. You can see there are all of the different models with different hyperparameters. And different models can be evaluated by methods such as drawing confusion matrix, calculating and comparing accuracy, processing, recall, and F1 score. All of the model will be loaded here. Like all of the model will use this function, load model, to load from the laptop to here, and their parameter will then be deployed and use different model to protect use the testing site, and different model will draw them confusion matrix and calculate the accuracy, processing, and recall and F1 score. And to obtain the optimal hyperparameter, and those best hyperparameter will then be deployed and used on the image data initially downloaded locally. Right here. And use the data augmentation for training set also. And now we deployed the best hyperparameter. We add extra convolutional layers, and the third convolutional layers. The number of filter is 128, and the dropout is 0.2, and the learning rate is the default, because the default is the best one. And we also defined a callback to save the model and set the early stopping and to save the log. And after 22 hours of training and testing, the best model can be obtained. And the confusion matrix and the curves is right here, and the confusion matrix is right here, can be drawn for evaluation. Okay, that's all. Thank you very much. Thank you for your listening.